So with you guys on page 6 of your packets right now, and we are getting ready to learn what to do if we have variables on both sides of our equation. All right, so we have right here, we're actually going to be solving the same problem. You'll notice it's the exact same problem. We're going to solve it 4 different ways, and we're going to then go to show that we're going to focus here on the last method, and we'll talk about a couple of reasons why. So the equation here that we have is 5f plus 3 equals 2f plus 9. And I actually have that modeled up here with this picture. We have 1, 2, 3, 4, 5 f's, and we have 1, 2, 3 on the outside. And what we're going to do is we're going to kind of think of these as boxes or bags, and the little boxes or bags have marbles on the inside, and we don't know how many marbles are on the inside. And on this side, we only have 2 of those boxes or bags, and we have 9 marbles on the outside. So the goal is to figure out how many marbles or that we have on each one of these boxes, okay? So we have 5f on this side plus the 3 represented over here. And on this side, we have the 2f plus the 9. And that's the equation that we have here for all of the problems. So the first thing I wanted you guys to do was to just try to think up here. So like if you wanted to try to figure out how many were in each box or bag, likely the first thing you're going to do is say, okay, let me get rid of these 3 marbles. Now if I take away 3 marbles from this side, I want you guys to think about, does this side get lighter or heavier? Well, this side just got lighter, so this side is heavier, and what's going to happen is this part will come down on the scale, and we don't want that to happen. So to keep it balanced, we're going to take away 3 marbles from this side as well. And that might be the very first thing. That's what I'm going through right now, y'all, is method A. The very first thing you might be tempted to do here is to take away 3 marbles from this side and 3 marbles from this side. That means all the marbles would be gone over here, so that would cancel out on this side, and we'd have 6 marbles left over here. Now when we do that, I want you guys to take a look at this equation. If you have 5f over here and 2f over here, we are still unfamiliar with what to do if there's still a variable on both sides. So that's why we want to avoid method A. Even though it makes a lot of sense up here in the picture to say, okay, let's get rid of our 3 marbles first. The thing is that next what you'd have to do is you'd have to get rid of these 2 bags, and then you're going to get rid of these 2 bags. And what's left would be this 1, 2, 3 bag has the same weight as these 6 marbles. So then you can split up the 6 marbles into the 3 bags, and that'd be 2 each. So this first method makes a lot of sense with what you're going to be doing in your head, but we're going to choose to avoid it simply because right here in our work, we're going to kind of be like, what do I do if I still see a variable on both sides? Now, another thing that you could do is to see that you have a 9 on both sides and to try to cancel out 9 on this side, and then 3 minus 9 would be -6. And once again, you're still left with an f on both sides of the equation, which is going to be why we want to avoid method B as well. Now, you'll notice that both of these methods move the constant first, and that's going to be your gut reaction to move the constant first. But if you move the constant first, then that means, again, you're still left with a variable on both sides, and that's why this is going to be unfamiliar, and we want to avoid these methods. Now, for method C, this is if you go after moving the largest coefficient first. So what we're saying is, let's take away all 5 bags over here, and that'll cancel out, and we'd be left with 3 marbles. But if you have the 5 subtracted from the 2, right here, you walk right on into having a negative coefficient. And honestly, y'all, it's going to be in our next unit when we're dealing with an inequality symbol. If this is the inequality that you have with a negative coefficient, and then we have our constant plus 9, you're going to have to remember to flip the symbol when you solve, because you're going to be dividing both sides by a negative right here. So later on, we're going to show like -9, -9, and over here you're going to get a -6, and then you have your -3f. But in the inequalities unit, the moment you divide both sides by a negative, you're going to be the one who has to remember to flip this symbol around for your final answer. So later on, when we're solving an inequality, if you have a negative coefficient, you're going to have to remember to flip the symbol. So what we want to do is we want to focus here on method D. You'll notice that with method D, it sets you up to have a positive coefficient. You're trying to get a positive coefficient out of this. And that's why method D is going to be our preferred method, so that we can set ourselves up for success later on in our inequalities unit and not have to worry about flipping the symbol, okay? So I'm going to walk you through method D now. And from the beginning here, if you have an equation with a variable on both sides, you're going to just simply ask yourself, what is the smallest coefficient? Well, in this example, one of my coefficients is a 5. The other coefficient is over here, and it's a 2. So which one is smaller between these two numbers? 2. So that's where we're going to start. Since 2 is positive, we're going to subtract 2f's from both sides. That cancels out over here. And you'll notice that we're left with something that looks very familiar. 3f plus 3 equals 9. And so now you're going to recognize that you just need to subtract 3 from both sides to cancel out the constant. 3f equals 6. You're going to divide both sides by 3. You have a positive coefficient. So when this is an inequalities problem, you will not need to worry about flipping it. And we get f is 2. So you'll notice for all of these problems, it doesn't matter how you solve it. You're actually going to get the same answer no matter what. But we want to avoid method A and B, which goes after the constant first. And the reason we want to avoid it is because that resulting equation still has a variable on both sides, and that just looks unfamiliar. Now, if you start by moving the larger coefficient, 5f and 2f, 5 is bigger than 2. So if you subtract your 5f on both sides to cancel it out, you're going to set yourself up to have a negative coefficient here, and that's why we want to avoid method C. So method D is the preferred method. You want to go after the one that has the smaller coefficient. If you subtract that from over here, you're left with a positive coefficient. And as you go on to solve, we get f is 2. All right. Now we'll talk about the check step with our new problem down here. I'll show you guys how to check with the new problem down below. But first, let's take a look at the equation. We have 12x minus 48 equals 60 minus 15x. So you'll notice we have a variable on both sides. And I'm going to highlight the coefficients so that they stand out to us. We have a 12 as a coefficient and a negative 15 as a coefficient. And y'all, between 12 and negative 15, which is the smaller number? Negative 15 is smaller. So that is where we're going to start. That is what method D says to do. So if you have negative 15x's on this side, you're going to add 15x over here and add 15x over here. That cancels out on this side, and we just bring down the 60. 12x's plus 15x's is going to be 27x's on this side. We have our constant of negative 48 equals 60. So now the next thing we're going to do is we're going to add 48 to both sides for this to cancel out. And 60 plus 48 is 108. Since our coefficient is a positive 27, we're now going to divide both sides by positive 27, and we'll get that x equals 4. So I want to remind you guys that it might have been your gut reaction to start by adding 48 over here, which is totally acceptable, but you still have x's on both sides, and that just looks a little unfamiliar. But it is not wrong if you wanted to do that. If you take negative 48 and add that on both sides, then your next part is going to look like 12x equals, and then you have 108 over here, and then you have your minus 15x. Remember, you added 48 to this 60. Then you'd need to remember to add 15x over here to cancel out. Add your 15x over here. And you're still going to be left with a 27x on this side. And you're still going to be left with equals 108. And you're still going to get x equals 4. Now let's move over here to the check step, okay? And I'm actually going to just kind of erase some of this stuff just so we can focus our attention now over here on the check step. So what we want to ask ourselves is, how is the check step different now that we have variables on both sides? Well, the difference is we don't know the total. We don't have equals a certain number over here to know what it's supposed to be. So it's different here because when we plug in and simplify, I should say, each side should equal each other. Here's what I mean. When we plug in x equals 4, that was our answer. When we plug it in on this side, we get 12 times 4 is 48. And then when we subtract the constant, 48 minus 48 is 0. Now let's plug it in on this side. When we plug in x equals 4, we've got 60 minus 15 times x. So 60 minus 60 is also a 0. So we didn't know going into the check step what they would both equal. We just know that they should equal each other, and we know we're good to go. I want to remind you guys that if you see something like 3x equals, let's just say 18, and then you know that x is going to be 6, when you plug that in, you know the total should be 18, and that's how you can check to see if you're right. That's what I mean right here when I say in this situation, we don't know the total. Instead, we just know that each side should equal each other. All right, I'm going to walk you through this next example here, number 2. So you've got 18y plus 24 equals 6y minus 12. Now you have a variable on both sides, so between 18 and 6, which is the smaller number, 6. So since we have a positive 6y, we're going to subtract 6y on both sides. This cancels out, and we're left with a negative 12 over here. You have 18y's minus 6y's on this side is going to be 12y's, and then I just bring down the constant. So now, because our constant's a positive 24, we're going to subtract 24 on both sides, and that cancels it out over here, and I bring down my 12y. And over here, when I subtract 24 from negative 12, I get a negative 36. Since my coefficient is a 12, I'm going to divide both sides by this 12. This cancels out over here, and we get that y will equal negative 3. So we're going to plug it in right here, and we're going to plug it in right here, and we're going to see if our two sides are the same. So on this side, we get 18 times negative 3 is negative 54. And when I add 24 to that, on this side, when I simplify, I get a negative 30. Now on this side, when I plug it in, negative 3 times 6 is negative 18. Now I'm going to subtract 12. And when I take away 12 from this negative 18, this side also simplifies to a negative 30. So I know that since both sides are the same negative 30 when I plugged it in, I must have plugged in the correct number. So negative 3 is the right answer because when I plug it in on both sides, I get a negative 30. All right, now let's flip over. And at the top here of page 7, I wanted to review with you guys that you might need to combine like terms or distribute before you have the equation with the variable on both sides. Let's take a look here at number 3. You'll notice on the left-hand side, on this side of the equation, I have an expression where I can take the negative 5r's and add 12r's to that and combine like terms to get 7r's. I'll just bring down the minus 3, and on this side there's only 2 terms, and now the equation is what we've been reviewing. Now you've got the equation with a variable on both sides, so you've got 7r's and 16r's, and 7 is smaller than 16, so you're going to start by subtracting 7r's on both sides. That cancels out over here, and 16 minus 7 is 9r's, and then you just bring down your constant. Now you're going to add the 21 to both sides to cancel out your constant over here, and we get 18, and now when you divide both sides by the 9, we're going to get that r is 2. So now let's check this work. We had a negative 5 parentheses times 2 plus 12 times parentheses 2 minus 3. That's one side. That's the original expression, and we're plugging in our 2. And when we plug this in, now let's simplify to see what we get on this side. This is going to be a negative 10. This is going to be a plus 24. And then we're going to have minus 3. So negative 10 plus 24 would be 14. And 14 minus 3, we're going to get an 11 on this side when we simplify. Now on the other side, we have 16 times this 2, and we're going to take away 21. So 16 times 2 is 32. And when we do 32 minus 21, we do get 11. So since 11 equals 11, we know that we plugged in the right number on both sides. So r equals 2 is the right answer. Now I'm actually going to not work you all the way through the next 2 problems, but I am going to remind you that for number 4, the first thing you're going to do is leave the negative 6u alone, and you're going to distribute this negative 3 to get a negative 6, and you're going to distribute the negative 3 to get a plus 3u. We've already reviewed how to distribute, and then right here that you need to combine like terms. So this negative 6u plus 3u is where I'm going to get my negative 3u. And then I have minus 6 on this side. Now I'm just going to bring down on this side the negative 4u plus 14. And this is when you should know what to do at this point. Careful though, between negative 3 and negative 4, which one is smaller? Negative 4 is smaller than negative 3. So the next step here is going to be to add 4u's over here and add 4u's over here. I'm not going to continue the rest of the problem because I want to check to see that you know what to do. And I also want to check to see if you know how to check your answer. So for number 5, also just be careful down here for number 5. Catch that on this side you want to combine like terms first, while on this side you want to distribute. And then you're going to be left with your equation with the variable on both sides to solve, and then come over here and check your answer. There will be a Google form now on pages 6 and 7 to check for your understanding, and for you to also note your answers to 4 and 5, and for us to make sure you're good to go with these problems. And that concludes this video. Thank you.